Hello everyone, welcome back to the channel. I hope you guys are doing great. So we will see today's daily challenge on Leetcode and we will try to solve it together. Okay, so let's see what the problem statement wants to say at first. So make the sum divisible by p. You are given an array of positive numbers, integers, and remove the smallest sub-array. Okay, sub-array means the elements are contiguous, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Okay, so the whole array is something you cannot remove. So smaller than the whole array, even possibly empty, you should try to remove, and return the length of the smallest subarray that you need to remove, and if it is impossible you need to return -1. A subarray is defined as a contiguous block of elements in the array. Okay, so it is told that you need to remove something, like, so if you try to see this example, 3 1 4 2. Okay, so right now what is the total sum? 3 plus 1 plus 4 8 plus 2 10, right? So right now the sum is 10. You need to remove something to make the sum divisible by 6. Okay, so 10 modulo 6, if you try to do, it means that if you try to divide the whole sum by p, what is the remainder? The remainder is 4, right? 10 modulo 6 is 4. So you would want to remove the 4 sum. Now in how many ways you can remove this 4? You see, this is a contiguous subarray 3 comma 1, which is 4, right? And this is also 4, but what you the third element, only the third element is also 4. Okay, so but you need to return the length of the smallest subarray. It is told in the question, smallest subarray. The smallest subarray length is 1 only. Okay, because only 4 removal will help you do the thing. Okay, so yeah, that's all about the problem statement. Now if you have not done this similar kind of problem before, you might think that this is very difficult, but it is not at all difficult, this problem, because this is similar to even the two sum problem. We will see how. If you have done the two sum problem, just try to quickly check that out. It is a very easy problem on Leetcode, and the optimal method of that uses this something similar idea only. Okay, so what is the thing which you need to see is that you are given this array, right? So you are given this array, okay, and you need to tell that. So first thing which you can do is sum up the elements. Let's say you calculate a variable sum, and at the end you just calculate sum modulo p. It means that this is the thing which you need to subtract. So as we saw in the first example, that for 3 1 4 2, what was our sum? Sum was 10, right? What we needed to subtract, so basically we needed to reduce this sum in order to make the result divisible by p. So definitely we will try to reduce something related to the remainder. So sum modulo p is nothing but 4, right? Because p is 6 over here. So you need to remove 4, and then you need to select that which subarray you need to remove. Okay, so so initially what you will do easily is that sum modulo p, you know, in your mind you are knowing that this sum modulo p you need to remove. Okay, so this is something you need to remove. Okay, so you just need that what is the subarray with minimum length. So the question transformed to finding minimum size subarray, okay, with sum p, because this is the thing which you need to remove out. Okay, with sum equal to this whole, let's say this is remainder I will call. So with sum equals to remainder. Okay, minimum size subarray with sum equals to remainder. So this is what you need to do. So for this the method is very simple. Actually it is a trivial problem. You store the prefix sums, right? So what will happen is that, you know that if you want a range, so if you want the sum of all elements within this, okay, what do you generally do? This I have told multiple times. You store the prefix till this and prefix till this and subtract the whole prefix. So let's say you have an array 6 1 5 3 5 2 3 4. Okay, so let's say you need this whole sum. So you create the prefix array 6, 6 plus 1 7, 7 plus 5 12, 12 plus 2 14, 17, 21, right? So if you create this array, you see if you subtract this 17, this whole thing minus this, you will get this result. So 17 minus 7 if you do, you get 10, right? And if you try to see 5 plus 2 plus 3 is nothing but 10. So without iteration by just subtraction of the prefix array, you got the result 10. Okay, so that's what something similar you need to do here. So you maintain a prefix variable and you maintain a map where you have seen the prefix variable so far. In toSum also we do like this only, right? And so what I want to do is that I will keep a prefix variable, okay, and prefix in every step I will do prefix plus equal to this array of I, nums of I, okay. So at every ith index I will have what is the prefix so far, and I will try to insert the prefix into the map, and I will say that let's say the map key comma value pair of the map will be nothing but prefix and the index at that the prefix occurs, okay. So what I am trying to do is that let's say I want to calculate this whole sum, just now I told you, right? So when I will be at this point, I will have my prefix and just check that what I want to search, I want to remove this remainder, right? So right now my prefix is something like this, so I will just search that prefix minus remainder, this value exists in the map or not, okay. If it is existing in the map, then what I will do, I will see that hey, when did it exist? So that's why index number is required. So it index exists, let's say at this particular index j, and I am right now at a. So I will just simply subtract this j minus I to get the length of this whole subarray. So the length of this whole subarray, whose sum is nothing but prefix minus remainder, right? So I hope this much you did understand what I am trying to say. So yeah, basically you need to remove so not remove, you need to just find, you actually need to remove, but what was the question is that you need to find the minimum size subarray with sum equals to remainder. Okay, so right now the sum is prefix, the total sum of all the numbers from 0 to ith index, it is prefix, and you want to check that before this element, before this, has there any value which is prefix minus remainder. So you easily understand that if the sum of all values till this is prefix minus remainder and sum of all values is this of this is prefix, then the sum till this will be remainder, okay. This much by easy observation you can tell, right? If this whole thing is prefix and this whole thing is prefix minus remainder, then this sum of the subarray, this portion of the subarray, this whole portion, that sum must be the remainder, okay. So yeah, that is very simple. And even if you try to take one example, okay, what kind of example? 3 2 6 5 2 and 8, let's say, and you're trying to find 7, okay. So you see that hey, my map contains something like map of 3, so prefix of 3 is lying at this index 0, right? My map will contain 3 plus 2 5 is lying at index number 1. Now the remainder, let's say the remainder which we are searching is 7, okay. So map of 5 plus 6 11 will consist of 2, the index is 2. Map of 11 plus 5 16 will have the index of 3. So map of now 18 till this, the remain index is 4. So if you try to see at each step, whenever you are storing this value, at each step, first you will also check that hey, my map of 18 is 4, then where 18 minus 7, since I am searching for remainder, I search for 18 minus 7. 11, my map of 11 is lying at index number 2, okay. So what is my length of the sub array? I have got a sub array. My length is 4 minus 2. So 4 minus 2 is 2. So you see a sub array ending at this point is the length is 2 and the sum is 7. I hope you do get what I am trying to say, right? And that is how we are going to solve the whole problem. And what we can do, see, there might be an integer overflow over here, right? So as we are keeping on adding elements, and each of the elements, if you see in the constraint, it can be 1e9 and there are 1e5 such elements. You might think that you will be storing them in long format, but it is better to store them in modulo p. Okay, so whenever we will do this sum, this 11 we will do modulo p, this 16 we will do modulo p. It is all the same, right? It will be all the same. And while searching also, what we are searching, prefix minus remainder, right? So you know how to, when there is a negative sign, how to do the modulo. It is very simple, plus p modulo p. Okay, this is how you do. Okay, so let's say prefix is 2, remainder is let's say 4. So minus 2 and let's say p is 6. So minus 2 modulo 6 is actually 4, but how you will get that? Minus 2 plus 6 modulo 6. That's how you do it whenever there is a negative sign and modulo is involved. That's how you calculate modulo if you do not know. Yeah, just you can Google it that out. And yeah, I hope that is all. For the explanation part, I will just try to code this out, and you just see. If you have any doubt, I will also definitely explain along the way. So we have n with us, and let's say we have some sum with me which is initially 0. Okay, so first of all what I do is calculate the initial remainder. So as I told you, as I will sum this whole thing and find the remainder. So let's do it quickly. For auto x, you just quickly go through the nums and just do sum plus equal to x. Yeah, so you have it, and you have the remainder with you, which is nothing but sum modulo p. Okay, so now you check that if see, there is also a possibility. See, you need to return the smallest subarray, so there is a possibility that you need to return the subarray of size 0. So how when will you return remove that subarray? When you do not need to subtract anything. So when the remainder is already 0, then the remainder is already 0, why do you need to remove any subarray, right? So I will just tell that if remainder is already 0, I do not need to remove anything. My length of the array which I will remove is 0. Okay, so I do not remove anything. The whole array is perfectly divisible by p. Okay, so we have this, and yeah, so we will go on. We have the remainder, and what we need to find, we will also have a prefix, right, initialized to 0, and let's say we also have an answer which is n. Okay, and we cannot remove the whole array, so answer cannot be really n. So let's see, we will try to minimize the answer, right? So we have this n iteration. So as we iterate, first thing which we do is calculate the prefix sum. So prefix plus equals to nums of I, as I told you, right? Now I will try to store each and every map element into the prefix. So map of prefix will be I. Okay, this is what I will try to store. Okay, one thing I just missed out, that you do map of 0 equals to -1. Do you realize why I am doing this? You try to see that you are storing each and every prefix sum in a map, right? But this is the index number 0, this is the index number 1. Okay, so what if I am searching for 5? How will you get it? So you have the prefix 5, but if you have something like map of 0, this prefix sum 0, so I am just telling that till the index number of -1 I am having a prefix of 0. So what does this map denotes? So I did not even initialize the map. So let me initialize the unordered map integer comma integer. Okay, so what does this denote? It simply denotes this prefix comma index. So till the index I there is a prefix sum of pref. This is what this map is telling me. So till the index of -1 the prefix sum is 0. This will allow me to take the sub arrays starting from the first element also. Okay, so yeah, that is what, and at every time we just do that till the index I, the prefix sum is nothing but this. But we will also check something, right? What are we trying to check exactly? If map.count prefix minus remainder is greater than 0. So if we find something like prefix minus remainder, as I told you, that is what we are doing over here, right? Yeah, I already explained this. Prefix minus remainder is something we will search, and if it is greater than 0, it means that if it exists, okay, if it exists, then what we will do, we will try to minimize our answer, right? So answer, so basically it will give the last pref seen at which index, okay. This will give me this, and this is I am minimizing this answer, which is nothing but current index minus the index obtained by the prefix obtained by this answer, right? And few things we need to do, as I told you, is that this sum. So let me try to make this long. First of all the values I will just try to make it long, okay. Nothing will happen even if it is integer. So yeah, we have it long, comma long. Now I will also try to put the modulo value, right? So this prefix I am just storing it in modulo. So as I told you, what I will try to do at the end is store these answers, these numbers also in the modulo p, because yeah, that will result in storing small numbers, and you know that will not make any effect, right? So this I can store modulo p, and while searching also I want to do this whole modulo p, right? But hey, I cannot do it very simply. I just need to add p also, because there is subtraction. So subtraction might lead to a negative value, and negative value requires some addition to be performed, okay. So plus p mod p, okay. So you have this, you have this, you are storing the prefix in the perfect manner, and I hope that will be all. So you see, answer is getting updated every time. So if answer never gets updated, answer is n, right? But you know that n, all elements you cannot remove, okay. Answer is the number of elements you are trying to remove. So if answer is n, you basically cannot perform this operation, so you return -1, else you simply return answer, okay. So yeah, that is what it is trying to say, and you see, that will be all, I guess. If you try to run this, let's see if there is any bug. You see, there are no bugs. I put some extra test cases here to make sure it works perfectly fine even after submitting. So you see, you have it. Yeah, we get the accepted thing. The runtime is not that great, but yeah, it can be better. You can try to do constant integer for this, okay, for some of the values. So long stores the 64-bit, right? So for safety purpose I did long, but you can try this with integer also. Yeah, but I guess that is quite okay. I mean, yeah, it is O of n solution only, because this unordered map gives you amortized O of 1. So yeah, that's all I guess for this problem. I hope you did understand. If you did not understand any portion, you can definitely ask me in the comment section. So actually this is a trivial method which is also there in the SD sheet. If you are practicing any SD sheet, in almost every SD sheet you will get this sub problem, not this problem whole, but this sub problem you will always get. This minimum sub size sub array with a particular sum, not remainder but a particular sum. So you will be given a particular sum k, so you need to find the minimum size sub array with sum k. So you can just search this problem also. So if you are able to solve this particular problem, if you are able to reduce the problem into this sub problem, then also you should be able to do this. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.